This is another barrel that I'm working on. I've shown one of these before in a past video, kind of recent. I'm making another one just like it. We got a couple more in here, and I had something different come up, and I thought I would go ahead and grab the camera and show you guys. So I've already got this fitting welded on, and we've got these threads turned so that once you weld this on, it's going to warp it some, so it's best to thread this stuff after you do your welding. The chances are, if you thread it and then weld this, your caps and your gland isn't going to fit. So we got that done, but we got to do an internal thread now. That's what we're getting ready to talk about. Here's the sample that we're going with, and the tube is bad because it's scored really deep on the inside, scratched. We already tried to hone it out, but it's they're too deep, so we're having to build another barrel. So what we got here is buttress threads, and that's why I'm wanting to show this to you. We haven't done buttress threads yet on the channel anyway. So here is the gland, and some of you may be asking, what is a buttress thread? Well, I'm going to try to show it to you. Now, I don't know if you can see it there. If I can get it to where, look at the top there. One side is flat, the other side is angled. You'll have a 45 degree on one side of the thread, and the other side is straight, like a 90 degree. Alright, so that's what we're working with there. I might try to draw it for you so it's a little bit easier to see. I don't have any inserts to cut buttress threads, but what I do have is this tool bit right here. This is what I use for all of my buttress threading. A piece of high-speed cobalt. And I believe it's this end right here that we're going to be using to cut our internal thread. I'll set up the other camera and show you one way that you can figure out, because it does get really confusing on which side, which direction you're going to be cutting. So there's a little hand drawing that I made to try to make it a little bit more understandable on the shape of a buttress thread. As I showed you, there's my tool bit right there. So as I'm coming in there and I'm going to be cutting an internal thread, that tool is going to be cutting that profile right there. So you've got one side is straight, the other side is 45 degrees. So you have side clearance there so that you don't rub the side of the tool, and of course you got your other relief there. I don't have any top rake angle or back rake or anything like that. It's just flat on the top, but that's how we'll be doing it right there. So this is simulating your inside diameter thread, and then this thread would be like your gland right here. Okay, so next question probably is, well, you know, why a buttress thread? Well, all I can tell you is that they say that it's stronger because of the two opposing surfaces that are pulling against each other when it's under pressure, is that these straight sides right here are stronger than a standard V thread. Now, as far as the data behind that, I'm not one to sit here and tell you whether or not that's true. I just know that a standard V thread will hold any hydraulic cylinder that we've built, and usually whenever I go and I rebuild these, I'll go back with standard 60 degree V thread. But since we're reusing this gland, we're going to go ahead and machine the barrel to fit that, so that we don't have to make this part right here just because of the thread. Alright, so I'll show you some footage along the way, because it's a little bit different setup than a standard V thread to cut these. Alright, here's one way you can check yourself on getting the proper tool. You can get this the wrong way. It's real easy to do. So you're looking at the side of the thread that you're actually going to be cutting, only we're doing it internal. So I'm going to put this tool right up in there, and it matches. It's matching in there. So what we're going to do is come over here, and I'm going to rotate it 180 degrees, and I'm going to stick it in there, and it's matching up. So I know that this is the end that I want to use. Alright, just put a blue dot there so we know that's the one that we're going to use right there. That's just trying to you know, remove any arrow any error, I mean making mistakes, because it's really confusing sometimes when you don't do this stuff every day. Okay. And again, I don't have the proper carbide insert, so I'm using the high-speed tools. We're going to set the compound at 90 degrees or parallel with the ways. This is one of the cases where I'll actually use the compound set this way. Instead of using a compound in feed, I'm going to be using the cross slide for the in feed. And what you can use this for with it set at 90 degrees is that as you're cutting the thread, if you find that you need to widen out the thread just a little bit, or you just want to kind of lightly skim one side of the thread or the other, you can make small adjustments here and use this to scrape your thread in. But most all the cutting will probably just be done by the cross slide in feed right there. So we've got that set on 90 degrees, and we've got our tool indicated in. I always like to indicate mine in square. That's about 6 inches across there, and we've got very little movement on the dial indicator. And don't forget, put a little A-bomb torque on there when you tighten it up. So we got to get our counter bore done in there, which is going to be 6 inches 95 thousandths. And I've got a stop set on the indicator there on the ways set to a 0. And once we get it bored to size, I've got the compound set on 20 degrees, by the way. Let me show you that. We set on 20 degrees. So once we get in there and make the final pass, I'll feed it in to cut a 20-degree angle in there. That's a good angle for allowing the piston seals to slide up inside that barrel. I'm doing my compound in feed. Right there you can kind of see the bore with a slight waviness to it on that edge. That's indicating a little bit of outer roundness from the welding. Shooting for 6 inches 95. Six inches 94. I think we're close enough there. We'll need to break this edge, put a chamfer there, and then we'll start setting up for our threading. I think I got everything set, ready to go to make our scratch pass. I've got a 0 set at my stop back there, and we've got our compound set at 0, and I've got an indicator over here. Let me show you that. I have my dial set to 0. We've also got this mag back indicator that's set right here, and this is to back me up here, because sometimes this dial collar right here will loosen up and then I'll lose my place. That's another reason why I like using the hard stop right here. So I can use this to verify that I come back to 0. So here we go. Let's go ahead and make a scratch pass. We're cutting 12 threads per inch. I'm going to be cutting this slow because we're using a high-speed tool. Can't run the same speed as we do with a carbide. Alright, I've got it set about 1/8 of an inch in front of that bevel back there so that I don't cut into it. Now you can use a standard pitch gauge to check it, and that's telling me that I'm on it. That's 12 threads per inch right there. All right, there we go. So let's cut about a 20 thousandths pass, see what it does. And I'm going to be smoking you up today, but we're not going to be filtering it through a cigarette. I'm sorry, AVE. Gotta wait for that thing to come around. You just gotta love the smell of cutting oil in the shop though, right? Alright, we're going to come back to our 0 and we're going to go another 20. There's our 0, so that was 20, so that's 40. And that's the one thing you got to do when you're using this cross slide in feed, is keep up with your cut every time. Make sure we got plenty of go juice in there. So each pass, it's actually cutting on that front edge, the angled part of the tool, as it gets a little deeper into that sidewall there. That was my last pass right there. We're going to go another 20. So that's 80 thousandths here, 40 thousandths to one side. Looking pretty good. I think we're going to go ahead and start checking our gland now. Getting to be a pretty deep cut there. Need to make another pass. 10 thousandths this time. It's almost there. It's starting to get tight there, but I can tell it's really close. By the way, I don't have no magic number. I go by how the thread looks and how it fits. I know I want it to fit good. So we'll go another 5 thousandths on the dial, because the pressure is still gonna be taking a cut even if I didn't dial it in any further. Yeah, that's still quite a bit of metal coming out of there, even with just 5 thousandths cut there. So I know Mr. Pete don't like this kind of stuff here, and he says don't use an air hose, but there's a lot of things like this that I couldn't do my job without a little bit of air. Getting all those little fine chips out of those threads, I gotta have my air. All right. Let's see if it fits in there. Still a little snug. We're right there. I mean, it's right on the cusp of fitting. So I just need to, I'm gonna make a spring pass and try to clean that thread up some more. It's getting right there where it needs to be. Just taking a couple more thou out of it. All right, let's see if we're gonna get lucky this time. Come on, man. First thing you gotta do is get it started straight. Feeling better. We hit our mark that time. Awesome. And then we got, I'll show you the other piece. Let me grab it. We got another cap that goes on this. This thing is double wiper. So you got a wiper that goes here, and there's another wiper that goes on a cap right here. But here's the other part that goes on top of it, like so. That'll get screwed on, and I mean, this is just how this thing was designed, so we just replicate it. So it helps retain that one, which really most of the ones that we do, they just push in and they're sealed with an O-ring, and this cap is what retains the gland in there. I've never seen another one where this is threaded in and a cap screws on top of it. That's how they built it. But you got two wipers right here. Your seal goes there, wear band inside there. All right, well, this is done except for some final polishing. I'll use my little polishing wheel and just smooth the threads up, make sure there's no little burrs on it to get caught in there. And I think this is going to be about the end of our little buttress threading session. So I hope you guys enjoyed it and maybe picked up a tip or two here or there on cutting buttress threads. There's more involved in it than what I showed, but we're just kind of going off the cuff as we always do here. All right, there we go. So what I'm working on here is a hydraulic cylinder. This is the eye that's welded on the end of the barrel. And what happened is that's a self-aligning bearing that gets pressed into that hole, and it got damaged and wallered out. So you got a couple choices on something like this. You can either cut that eye off and make a new eye welded on, or you can bore it out, make a sleeve and put in there. So this time we opted to go ahead and bore this thing out, sleeve it, get the job done a little bit faster. I don't have any, that's 1.5 inch thick plate, and I don't have any of that size around here, so we would have had to order a piece. So I'm just doing with what we got here. But what we'll do is we'll bore that out. I'll machine a couple bevels on each side, and then we'll use, I got a piece of tubing right here, 2 3/4 by 4, and perfect size. That's a drop. I'll chuck this up and I'll machine it to press into there and weld it on each side, and that'll bring it back to size where we can press our bearing back in there. I want you to take notice of the speed at which I'm boring this hole at. Obviously we're on the board mill, so we're not having to use a criterion head, but I'm removing an 1/8 inch of material, 125 thousandths. Got a nice chip formation there. I'm not running real fast. I don't have a super aggressive feed rate. That's a good speed to run that at. That's a half-inch high-speed steel tool bit that I ground. That's a fresh one. I'll show you the tool bit later, what it looks like. But whenever you're boring using say like a boring head, I've mentioned this before, I notice a lot of guys run those boring heads really fast, way faster than I run it. And I'm not saying that that's wrong or that I'm right. I noticed that this works for me. I like to run them kind of slow. I don't like to run them fast, especially when you got an offset like that. It just seems to shake the mill around. I like to run it low and slow, and it gets the job done in fine fashion for me. So I'm just about bored to size. I'm taking this to like 4 inches. I think I'll have like maybe one more cut to do after this one here. Last cut, this will bring us somewhere really close to 4 inches. I'm not trying to hit a real target size. And I wanted to show you, this is actually the tubing that I'm going to use right here. That other piece that I just showed you, I forgot was cast iron, so I need to mark it on there what it is. But after I turned the video off, I realized that's not steel, that's cast. This is DOM tubing right here, heavy wall stuff. We'll make a sleeve out of that and get it welded in there. I use a little bit of cutting oil just to help the shearing action on the tool bit there. And you see the chips down there. That's pretty nice chip control. I'm real happy with the way that tool's cutting there. Now that dark spot, the dark spot you see there, that's a cross hole drilled in there for grease. So once the sleeve's welded back in there, I can probably just reach in there with a hand drill and just drill a hole so that the grease will come back through there like it's supposed to. All right, there's my tool bit we're going to use to cut a weld chamfer on each side of it, or a weld bevel. Here's the tool that I was using to bore it out. A very simple grind. We've got a little bit of side and back relief on the top edge there. And of course you've got your side relief here. So it'd be cutting like this. Alright, so we're going to go in there with this tool now. And I slowed it down some. Just hand feed in. Use a little bit of oil there. I'm just feeding the table into the tool bit. Low and slow wins the race. I think that looks pretty good. I'm just going to eyeball it, and I think that looks like it's on size. So we'll do the other side just like that. From here though, let's move on and get the sleeve made. Alright, so our bearing measures 3 3/16. nominal size anyway. It's actually over that. So here we got 3.187.5. So it should be a nice press fit for this bearing. Actually, if I was to mic it, you're going to show about 193, but these are made with a split, so they compress a little bit as you press them in there. Yeah, that'll be a nice press fit right there. Just using this oil as a lubricant. Alright, I want to go ahead and cut a weld bevel on there now before I get in there too far. Get rid of some of that. I think that looks pretty even. Just leave it there. Come in back to my zero here. There we go. I'm just over here talking to myself. My coworkers are giving me funny looks because I'm talking. There it is. After welding and cooling, I had about 2 thousandths undersized from what I wanted, so I was using the flap wheels there to try to flap it back out to size. That first one that I was using is just a shop made flap, 1/4 inch rod with a slit cut in it, and you put some emery paper in there, and those do really good for polishing up any kind of bore. But what I'm going to have to do is go ahead and switch over to a more aggressive style flap wheel, which is what I'm showing right here. Go in there and flap it out with one of those, and that, once I flapped it with that for a little bit, it brought it back to size of what I wanted. So this is pretty much the end of this segment. It's what I wanted to show you on how I bore and sleeve a tube end like that for a mounting plate, an eye self-aligning bearing. Put it in the boring mill, bore it out, and make you a sleeve and weld it in. And then sometimes you got to come back here and polish it back out a little bit.